Good afternoon, students. Welcome to the lecture of Operation Research. I heartily welcome you all in the semester 4 of your MSc 2 Mathematics course. For this semester, I am teaching a paper of Operation Research. Let me just tell you briefly what is the syllabus for Operation Research. There were in all 4 topics under this paper of Operation Research. In the first unit, we are going to study some basic operations, basic concepts, basic definitions which are required to understand linear programming problems such as convex sets, supporting separating hyperplane, etc. Also, in the same unit, we are going to study the introduction to linear programming problem and trying to understand some 2-3 methods to solve a linear programming problem, such as graphical method, simplex algorithm, two-phase algorithm, and big M method. In the second unit, we are going to study the duality in linear programming problem. Also, a new type of linear programming problem called as integer programming problem. Third unit is deal with quadratic programming problem, and in the fourth unit we are going to study a special type of operation research called as theory of games. All of you are familiar with what are the games. I think all of you like to play the games as well. In this fourth unit we are going to understand the theory that how a game should be played. Okay, this is what the syllabus is. Now in today's lecture we are going to start with the first unit. Okay, and also we are going to understand what is this word operation research means to us and how the linear programming problems can be studied. In your 12th standard, you have studied the linear programming problems, correct now? You have rather formulated the word problems in order to solve this by using a LPP methods. Now in today's lecture, we will just try to understand why there is essential to formulate the problem into a linear programming problem and how it can be done. Okay. Before that, if you observe this name operation research, what idea comes in your mind? Operation and research. What you feel, what should be this combination? Operation research. There are many definitions of operation research. If you just search on Google, you will find many definitions of the operation research. Actually, operation means it is somewhat surgical. No? In medical field, doctors were doing surgical operations. And research is the word having re plus search. The things which we have already with us, we are going to research it. That is, we are going to make the things very fine. Therefore, together this operation research means a systematic method, systematic methodology in order to solve the daily life problem occurring. Daily life problems occurring. While searching the definitions of operation research, the definition which I like most is this is art of winning a war actually without fighting it. But I'll just write it. This is an art operation research is an art of winning a war, art of winning a war, without actually fighting it. Without actually fighting it. Don't take the meanings word to word. Actually, the meaning of the statement is the problem we can solve. Suppose we have one problem with us, and if I can solve the problem without actually going through with the physical situations, right? Suppose we are facing with a problem. Suppose we have our own business and we want to make the profit. No doubt, if I'm having my own business and I surely want to make the profits from that business. Then actually uh, without going to the business, without actually selling the goods and all, if I guess that what amount of quantity I should purchase, and what should be the rates the product should be sold so that I can get the profit. Means this is actually without doing the business. If I can calculate, or approximately I can calculate the strategy for doing the business, then this is called as winning a war without actually fighting it. Okay, actually in 1947, George Danzig and his associates, while working in the American Force, observed that large number of military programming and planning problems. See what I am saying? Large number of military, army programming and planning problems could be formulated as maximizing or minimizing linear form of either profit or cost function whose variables were restricted to the value satisfying system of linear equations. Okay, what I'm saying, in 1947, American mathematician George Danzig, they were working for US military. Were working for US military, and they have observed that programming and planning problems that were there in the military can be formulated as maximizing or minimizing a linear form, okay, of or profit or cost or any other objective function. Therefore, observing this, they have formed, or they will come to know that many problems in real life also can be solved without actually facing the problem. Without actually facing the problem. And this George Danzig is the first who has given the first technical method, mathematician who has given the first technical method to solve such a kind of linear programming problem, and the method he has developed is called as simplex method. The method he has developed is a simplex method. Okay, now whatever this linear programming problem we were saying, the situation we are going to formulate as one of the problem, and the problem is called as linear programming problem. Okay, now the word programming, whatever comes under this discussion, refers to the process of determining a particular program or plan of action. If I just write what is programming means here, the word programming refers to process of determining a particular program, process of determining a particular program, or one can say it's a plan of action. Correct. Now whenever we want to execute any activity, one should be ready with the plan how you are going to execute that activity. Suppose you want to pass your MSc course, suppose you want to pass your semester 4, then you should be ready with the plan, that how you are going to make the study, how you are going to complete your seminars, how you are going to complete your project, how you are going to face your internal test, and so on. Okay, means how much time you should give for project, how much time you should give for the preparation of seminar, how much time you should give for the preparation of your theory exam, for the practical exam as well. Therefore, whatever is this process of determining a program, or in the simple words one can say it's a plan of action. This plan of action is nothing but a programming. Here the word programming doesn't mean actually the programming with some programming languages that we are using in computer science. Okay, therefore programming is the word we are referring with the plan of action, or the process, or the steps that we are going to follow to complete that activity. To complete that activity is called as programming. And why the word linear was used? Because whatever is this programming we are going to make, this can be executed with an objective function which is a linear function of the variables. This is the linear function of the variables. Therefore, combinedly we are going to call it as linear programming problem. In short, we are going to write it as LPP. In short, we are going to write it as LPP. Okay, therefore, our operation research is a branch of mathematical science. Is a branch of mathematical science which gives us the plan of action or special steps or programming which helps us to solve the problem without actually going through the problem, without facing the problem actually or physically, one can say. Okay, but this methods were going to help us always while doing many types of activities or many types of dealing with many types of problems. Suppose I want to start up my business, then what should be my obvious policy while starting up my business? Okay, there should be two criterias. First criteria is either I should want to maximize my profit gained from the business. Okay, therefore the aim is to maximize the profit gained, or the other way is I should minimize the cost. I should minimize the investment which is to be done in my business. Therefore, one can follow any one of the criteria: minimizing the investment or cost, or maximizing the profit. Okay, if it was taken under military circumstances, then what should be my problem? What should be a problem? Suppose there is a war going in between two different countries, and one country want to solve this problem by using operation research. Then what are the constraints? The constraints for describing a problem will be number of soldiers, number of weapons, okay, number of many other equipments which are necessary, or availability of the restrictions if we want to deal with a problem regarding military. Regarding military. Suppose we want to play a game. Suppose we want to play cricket game between two teams. Okay. Then what should be the objective function in this case? No doubt, winning a game will be my objective function. Winning a game is an objective function. Then what are the constraints imposed on this kind of game? Number of constraint, because number of players are fixed in cricket. No, this is the way of playing. This is the method of playing. Suppose bowling or batting by the corresponding player. These may be the constraint. No, because we are familiar that opponent team is going to select the bowler depending upon knowing who is the batsman in the front. Correct now. Suppose Sachin Tendulkar is going to bat, then they have to decide which bowler will be suitable. If it is Virat Kohli, correspondingly they have to change their bowling. Therefore, these are the constraints on the game. Therefore, operation research is simply a systematic procedure or systematic steps which actually helps us to solve your problem without facing the problem actually or physically. Therefore, this definition suits very much that operation research is an art of winning a war without actually fighting. Without fighting, we can win the war, and that's why this is an important branch. It has a large number of application in society. This has large number of applications in society. Now, first, what we are going to today do in today's lecture is we are going to formulate one problem. Okay, we are going to formulate one daily life problem to a linear programming problem, and then later we will try to understand how these linear programming problems can be understood. Okay, so for here I will write formulation of LPT. Formulation of a LPT. Now, in order to formulate a linear programming problem, I will take a very simple problem of production allocation. Okay, the problem under the consideration is, suppose we have a firm of manufacturing, and where we are going to manufacture two types of products, say A and B, and we are going to sell each one of them at a profit of rupees 2 for one product, profit of rupees 3 on another product. Let me write it simultaneously. A firm manufactures two types of products, two types of products A and B, and sells them at a profit of rupees 2 on type A. Means if we sell 1 unit of this type A product, then we will get a profit of rupees 2 and rupees 3 on type B. On type B. Then we will go for knowing the what are the investment cost. Okay, each product is processed on two machines. Means we have only two machines G and H, comma, type A require processing. Type A require 1 minute of processing time on G and 2 minutes on H. Similarly, type B requires 1 minute on G and 1 minute on H. 1 minute on H. Okay. And one more constraint is given that the machine G is available for not more than 6 hours 40 minutes, while machine H is available for 10 hours during any working day. Okay, and the question is formulate the problem. As linear programming problem. See how much information is given to us. Lot of constraints, lot of information was given actually. There is a firm which is going to manufacture two types of products A and B, and each product is sold out at the profit of rupees 2 on type A, profit of rupees 3 on type B. Also, each product is processed on two machines G and H. Type A requires 1 minute of processing time on G, 2 minutes of processing time on H. That of type B requires 1 minute on each of the machine, and the machine is available, G is available for not more than 6 hours 40 minutes, while machine H is available for 10 hours. Now we want to execute. Suppose these are the restrictions known to us and we want to maximize the profit. From this manufacturing firm. Then one should know exactly what should be the criteria for selecting or for producing type A types of good or type B goods or type B products. Okay, so let us try to formulate the problem. Is the problem understood to everyone? Now we will go to formulate. Yes, students?
Yes, ma'am.
Okay. Now we will go for formulating the given problem. Now whatever is this data given to us, this was given with a large number of constraints. Constraint means large number of restrictions are there. No? Therefore, in order to formulate this, what I am going to do is I am going to prepare a table which will give us all the conditions imposed. Correct? So the table I am going to uh, prepare is first I will write machines. How many machines do we have? Two machines we have G and H. Okay. Then I will write time of products because time is also an important constraint condition. Time of products for type A how much it will take and for type B how much it will take. For type B how it is going to take. Now let us suppose we are going to manufacture X1 units of type A product and X2 units of type B product. Okay, what is the assumption? Let X1 be the number of, here I can let X1 be number of products of type A. Okay, and X2 be the number of products of type B. Okay, so here I have written type A, X1 products, type B, X2 products, and here I will write available time. Now, if you look at the time, first machine G is available for 6 hours 40 minutes. That of second machine is available for 10 hours. But either we have to convert everything to hours or minutes. Yes, we should take the time availability time into same units, either in hours or in minutes. Therefore, here what we will do, we will convert it to minutes. For 6 hour 40 minutes, how much it will be the time? For 6 hours, each hour takes 60 minutes. 6 is a 360 and 40.
It's 400.
This is 400 minutes. Here I will write in minutes. The top second machine is available for 10 hours, therefore it is 600 minutes. Now, type A product, how much time it will take on machine G? How much time it will take on machine G? 1 minute it will take. That of type A, how much time it will take on machine H? See, let us recall. Type A requires 1 minutes of processing on G and 2 minutes on H. 1 minute on G and 2 minutes on H. That of type B product takes 1 minute each. Type B requires 1 minute on G and 1 minute on H. 1 minute on G, 1 minute on H. Now the important aspect is remaining, that is profit per unit. Profit per unit. Now what is the profit per unit of type A? This is rupees 2. And what is the profit per unit for type B products? This is rupees 3. This is rupees 3. Is the table understood? Just we have written whatever is the information given to us. Right? Then if I am going to assume that X1 units of type A product is being manufactured, X2 units of type B product is manufactured, then can anyone tell me what will be the total profit if I produce X1 units of type A and X2 units of type B? Yes,
It's
students,
2x1
can
plus
you?
3x2.
Good. This is 2x1 plus 3x2. Why? Because selling 1 unit of type A product gives me 2 rupees profit. So for selling x1 units of type A will give us 2x1 as a total profit. Similarly, selling 1 unit of type B product gives us rupees 3 as a profit. Therefore, selling X2 units of type B product should give me 3x2 as a profit. The total profit gained will be 2x1 plus 3x2. Shall I write here? Since the profit on type A is rupees 2 per product or for 1 unit per product, then 2x1 will be the profit on selling x1 units of type A. Correct, na? Similarly for type B. Similarly, 3x2 will be the profit on selling x2 units of type B. If what is my total profit? Therefore, total profit. What is the total profit? This is 2x1 plus 3x2 and E is called as what I am going to do with this objective function, whether I want maximization of the profit or minimization of the profit.
Maximization.
Yes, it should be a maximization of a profit. If that cost is nothing but investment cost, if suppose, then it would be minimizing the cost. Correct? Na? But depending upon the objective function, you have to think of what should be the criteria of optimizing, whether it is minimizing or maximizing. Now, this is what about the profit we have thought of. Now, we have two more constraints also. Na? We have two more constraints. What are the two constraints? Time, processing time for type A products, processing time for type B products on machine G and H, and availability of time. See, 1 unit of type A requires 1 minute on G, okay, that of type B requires 1 minute on G. Therefore, how much time required for producing X1 units of type A on machine G? This is time required to produce or to manufacture X1 units of type A product on machine G. May I say X1 minutes? Similarly, type B, 1 unit of type B requires 1 unit of type B requires 1 minute on G. Therefore, how much this X2 units will take? Type B X2 minutes. Correct, na? Therefore, what is the total time of processing on G? For X1 units of A, X2 units of B. Is it X1 plus X2? स्टुडंट्स लक्षात येते का बघा आणि काय सांगते.
Yes, ma'am.
एक युनिट टाइप ए चा प्रोसेस करण्यासाठी 1 मिनिट लागतोय जी वर. तर x1 युनिट्स प्रोसेस करण्यासाठी किती मिनिट लागतील? x1 मिनिट्स. टाइप बी चा 1 युनिट प्रोड्यूस करण्यासाठी 1 मिनिट लागतो जी वर. x2 units produce करण्यासाठी x2 units. So what is the total time on machine G required to produce x1 units of type A and x2 units of type B? Total time.
x1 plus x2.
Good. This is x1 plus x2 minutes will be required on machine G. But finally, how many minutes I can use the machine G? What is the available time?
400.
400. Therefore, may I say this will be the first condition that machine G can be run for maximum 400 minutes, and every type A and type B will take in all x1 plus x2 minutes for processing of both the products, and which should not exceed 400. Correct now? Which should not exceed 400. Therefore, may I say this will give me one condition or one constraint that x1 plus x2 is less than or equals to 400. We cannot exceed 400 now, because the time is available for this machine G is available for not more than 6 hours 40 minutes. Not more than 6 hours 40 minutes. Okay, so let me write this also. Since machine G takes 1 minute time on type A and 1 minute time on type B. Therefore, the total number of minutes required on machine G How much will be the total time required? This is x1 plus x2. What shall I write for x1 units of product A, or x1 units of type A, x2 units of type B. The total time is, may I say x1 plus x2? Total number of minutes required on machine G is x1 plus x2. Therefore, may I write similarly? What is the total time on machine H? For 1 unit of type A, it will take 2 minutes on H. 1 unit of type B will take 1 minute on H. Therefore, what is the total time taken by x1 units of type A? Is it 2x1?
Yes, ma'am.
Similarly, producing x2 units of type B on H will take x2 minutes.
X2.
Therefore, what is the total minutes required to process? This is
2x1 plus x2.
x2. Similarly, total number of minutes required on machine H. Therefore, may I write this is 2x1 plus x2. This is the total time on G. This is the total time on H. But we know that machine G cannot be run for more than 400 minutes, and machine H cannot be run for more than 600 minutes. Therefore, what is the first constraint? But machine G is not available for more than 400 minutes. Therefore, may I write x1 plus x2 must be less equal by 400. 400, we cannot go beyond 400 minutes. Similarly, machine H is available for 10 hours. Means we cannot go beyond 10 hours. Therefore, may I write what is the total time on machine H? This is 2x1 plus 2x1 plus x2, which cannot go more than 600 minutes. Therefore, these are the two constraints. Similarly, whatever x1, x2 we have assumed, What is x1? X1 is the number of units of product type A. X2 is the number of units of product type B. Therefore, these two values cannot be negative. X1 cannot be negative, X2 cannot be negative. Therefore, we can add two more constraints that X1 must be greater or equal by 0 and X2 must be greater or equal by 0 because negative quantities are not allowed. Therefore, what we have done? We have done a mathematical formulation of the given problem of finding a maximized profit subject to these limitations. Okay, therefore let me consolidate my problem. The problem will be finding x1 and x2 such that this profit 2x1 plus 3x2 is maximum and which has to satisfy the two conditions x1 plus x2 less than or equals to 400, 2x1 plus x2 less than or equals to 600. Similarly, x1, x2 must be non-negative. Therefore, here one can write down. Hence, the problem is formulated as what is the formulation of our problem? Find x1 and x2 such that the profit, let me call it as P. The profit P equal to 2x1 plus 3x2 is maximum. Is there anyone present here who want to minimize the profit if you are running the business?
No, ma'am.
Subject to the conditions. What are the conditions? X1 plus X2 could not be greater than 400, means less equal by 400. Similarly, 2x1 plus x2 less than or equals to 600 and x1 greater equal by 0, x2 greater equal by 0. Therefore, this is the mathematical formulation. This is the mathematical formulation of a given problem, and if we solve this mathematical problem by using any of the standard methods of operation research, then we can go with the methodology of producing x1 units of goods of type A, x2 goods of type B. Otherwise, it will be a trial and error method, na? Let's suppose I will produce this 10 units of x1, 20 units of x2, and then I have to check whether the profit will be maximized or minimized. So, instead of doing that trial and error method, if I solve this mathematical formulation, then it will help us to maximize the profit and produce those many number of x1 units of type A and x2 units of type B. Correct? That's why we can say that these methods, these linear programming methods or operation research helps in solving the problem without actually executing it. Okay. Here, whether we have executed the business with trial and error, no. This the problem was stated, conditions are known. Therefore, this was the mathematical formulations we have done. These are the mathematical formulations we have done. If we solve, it will give us the values of x1 and x2, and we have to produce those many units of x1 units of type A and x2 units of type B only, so that the profit under the consideration will be maximum. If you have any kind of difficulty during this formulation, you can solve. This is just an example I have taken. Many more types of examples you have done already in your 12th standard, formulating a linear programming problem. Do you remember which method you have used for solving such a type of problems?
I remember graphical method.
Yes, graphical method is one of the most promising and simplest method we have used in order to solve such kind of linear programming problem. Okay, but there are limitations to graphical problem. The important aspect is we can use this method only for the problems where we have two variables. If the number of variables exceeds by 2, we cannot use the graphical method. And for that purpose, there is a need to define or develop the new kind of methods which can be used for the variables greater than 2 also. Okay. Therefore, in today's lecture, we have understood how to make the formulation of LPP. Make the formulations of LPP. In the next lecture, we are going to solve these problems by graphical method. These problems by graphical method. Actually, it is more difficult for us to show this on a plain paper by graphical method. Therefore, I request all of you to be ready with the graph papers. Okay, be ready with the graph paper. I will show you on this plain paper, and you have to execute with me on graph pages. Is the point clear to everyone? Once we
Yes, ma'am.
solve this by graphical method, then we will go for understanding the basic notions which are useful to solve these problems by the special methods such as simplex method, two-phase method, and etc. Methods are very easy of these linear programming problem, provided you should understand this. Once you understand the methodology of solving a linear programming problem, it will not give us any kind of trouble. Okay. Therefore, we will stop for today. In the next lecture, we will solve the linear programming problem by graphical method, and then we will proceed with the next methods. While solving the problem by graphical method, I think you remember whenever we are going to plot the line of the given constraint, if the constraint is of less equal type, we are going to consider the region below the line. Do you remember? And if the
Yes, ma'am.
constraint is greater equal type, we are considering the region above the line. You have to tell me the reason behind these two steps. Why for less equal region below the line? Why for greater equal type of inequalities the region should be selected above the line? Okay. Therefore, just find the answers for the two. In the next lecture, we will go for the graphical solution of the method. We will stop for today. If you have any difficulties, you can ask. If not, thank you for being with me for this lecture. Thank you.
Thank you, ma'am.